On stage, you see Yogesh Jain, who will tell us today more about how we can monitor Postgres efficiently and without vendor login.
So, hello everyone. So as you know, here's my topic. I'm going to present on this unified observability. We will see how we are going to monitor Postgres, which might be running anywhere in any kind of platforms. It may be bare metal or in some managed cloud offerings or Kubernetes self-managed things. So a brief introduction about myself is that I'm working as a staff SD at Enterprise DB, and we are building this hybrid manager, where basically we are providing the managed Kubernetes service in bare metal that can be deployed in a, a system, or basically the core idea is that we can monitor, like my team is basically working on observability part, where we are focusing on monitoring, collecting all the telemetry data from different platforms in a single pane of glass, so that the user or the DBAs, whoever is using the platform, is having the unified view to take better decision and to achieve better efficiencies and high availabilities. So if you see, like nowadays, the systems are becoming more and more complex, all kind of modern applications because of the users, and we are basically following this hybrid approach where we have this, instead of monolithic architecture, nowadays we have this distributed architecture where basically things are running on microservice, and they are fragmented across different platforms based on the use cases. Like some prefers bare metal, some prefers to deploy it on cloud based on their requirements. So the key challenge we face here is the lack of end-to-end visibility across these platforms. And what we have done so far is that we were using multiple monitoring tools to monitor these things. And it is making very complex to debug and resolve the issues. And because we have this different monitoring tools, this data are separated, and they are basically, the key challenge here was the correlation thing. Like we were not able to correlate the data from different platforms. So the main challenge was to resolve the issues or figure out what went wrong in different platforms. And sometimes it's too late to, which results in the lack of high abilities. So recently, the CNCF and other folks worked together and made this thing possible using OpenTelemetry, where we have the solution which is vendor neutral. Like if you see, there are multiple monitoring tools, but there was no standard protocol to use that. And for that, OpenTelemetry came, and it provides an open standard for collecting all the telemetry data across different platforms. So I'm going to talk in brief about that, and here is the agenda. Like I will start with the fundamentals 101, that is what is basically the observability is. And then we are going to focus, because it's a Postgres conference, as you guys are interested in Postgres, so we are going to focus on how we can monitor the Postgres and how the OpenTelemetry fits in this picture. And we'll see how we can monitor different platforms here, followed by a demo. Like the end goal is to do something like this, where we will deploy a Postgres cluster in Kubernetes. Maybe like we will use the most famous operator, Cloud Native PG here. Then we can deploy the Postgres in bare metal. And then we can also see if the time permits. We can check for the managed cloud offerings and try to monitor that as well using OpenTelemetry. And we'll get into brief details on how we will achieve this unified thing altogether. So here is the observability part. Like by observability, like what do we mean? Like we want to observe our system's internal state. Basically, we want to understand what's happening inside our system, and what is it going the right way, or something is off. For observability, there are basically three pillars. First one is the metrics. Metrics are like the quantitative data over time. Like if we want to understand, like how many people are watching that particular movie in Netflix at that particular point of time, so that Netflix can monitor the data over time. Some standard technical example is the CPU usage over time at particular point of time. So we can call that as metrics. The second and the most important thing which we all are familiar with are the traces, where basically we are having the event records. We capture the events, and basically we see the text records, and they are classified generally in different categories like warnings, errors, info, etc. The third and the most important pillar here is the traces, because nowadays, as I mentioned earlier, the systems are getting complex and they are no more monolithic. So we need to trace basically we need to trace the services, like when the request flows from one service to another, we want to know like what is going well or what is not going well. So for that, we have these traces. But right now, for this conference, I'm going to focus mostly on the metrics and the logs, because that's what we have with Postgres at the moment. So first of all, to achieve observability, we need to make our system observable. So in case of an application, we need to instrument the application in a way that it emits telemetry data. Telemetry data are again the same, the logs, metrics, or traces. Once we have our application instrumented, we can basically send all this data to observability backend to visualize the data and monitor it, set the alerts to receive some pager information that this was the threshold. Like for example, the CPU was like over 80%, and we have set the threshold at 80%. So we'll receive a notification, so we can act accordingly, and we can trace what went wrong with that and see the logs, etc. So we need to first of all instrument our application and then send all this data to observability backend to basically analyze and gain insights. Here I'm just focusing on the open source tools. Like the most famous battle tested tool was is the Prometheus. For metrics, then for logs we have this Grafana Loki and FluentBit. Then we have Jagger and Grafana Tempo for traces. And finally, we have this Grafana, which can basically visualize and collect all this data in a single pane of glass here. So we will use Grafana here. Now, we have this monitoring Postgres. I'm not going to talk about the Postgres, but mostly on what, because we don't need to make the Postgres observable. It's by default emitting the logs, but we can use the SQL queries and pgstat plugins or different kind of plugins to extensions basically to retrieve some monitoring data. So here, how we can monitor the world's most advanced open source RDMS. For the metrics one, we can first of all track, like these are some of the fundamental metrics which we can focus on is the, for example, our Postgres is running on a bare metal cluster, so we can track some resource usage like CPU, memory, disk, IOPS, etc. We can also track the query performance. We can check the query latencies through metrics. Then we can also track the connections, that how many users are connected or how many clients are connected to that database or other database health, like in case we are deploying our system as high availability, the Postgres is high availability, so we can monitor the replication lag, etc. And we can also set threshold based on that. Then we have this errors, like we can keep an eye on errors. We can run our own custom SQLs to get custom metrics to basically retrieve those data. Next is logs. For the logs, as you know that we have the option in Postgres to monitor different kinds of logs, like the error logs, warning logs, connection logs, or the statement logs. Like if I go in detail, like for the error logs, we can monitor, we can basically check for the dead logs. In case of warning logs, we can check for slow queries. For the connection logs, we can track the connection and failed login attempts. In case we need some audit or compliance thing. And for the statement logs, we can use some extensions like PG audit and other extensions to basically get the queries for auditing. So this was like how we can monitor the Postgres. Now, focusing on the core thing which will which will connect all the dots is the OpenTelemetry. OpenTelemetry is the open source observability framework, which will basically help us to unite all this kind of data from different platforms. So again, the concept of observability is the metrics, logs, and traces. First of all, we need to generate the data by making our system observable. Then we need to collect this data in a single place so that we can do some processing in order to add some labels or like to basically categorize our metrics, logs, or unify them using a correlation ID or something like that. And then finally, we can export this telemetry data to the observability backend of our choice. First of all, I want to focus on this part that it is a framework and it provides an open standard. It is not an observability backend. It does not store or visualize the data. For that, we need to use any other tool. We can write our own custom UI, or we can rely on Grafana, the most popular one for visualization. So here are the key characteristics here. Like as I mentioned earlier also, that it is open source and it is vendor neutral and tool agnostic. Like it supports multiple tools. So we can basically plug it to a different multiple backends, like open source tools, again, Prometheus, Loki, Jaeger. There are some commercial platforms also which nowadays highly supports this OpenTelemetry thing, because they know that this is the future and they are trying to get all the data in the platforms like Grafana Cloud, Datadog, New Relic. The most important thing is that, like, when you start using OpenTelemetry, it is very easy to use and basically instrument. There are some things which does SDK support, or it supports the most popular multiple languages, so that it is very easy to instrument our application or any kind of application, in fact, modern applications. And the most important and which is required in today's world, as we are going from cloud to, again, hybrid thing, is that it can be deployed on any kind of infrastructure, like the Kubernetes, bare metal, or VMs. By Kubernetes, you can use the OpenTelemetry collector image to basically deploy those things. For the bare metal, you can use the binary compiled in your platform, like ARM64, AMD64, whatever, and you can also run on VMs. Here, I forgot to mention that the short form of OpenTelemetry is OTel. So for now on, we can refer to that as OTel. And here's the data pipeline. As we can see that we need to instrument our application so that it emits telemetry data. Then we need to use something called as OpenTelemetry collector, where the magic happens. Like, it basically has 3 modules, which I will go in detail next. So the task is very simple of OpenTelemetry collector: to receive the data, then to process it, and then to finally export this data. So again, the data can be sent, I'm mentioning that again, that it can be sent to any platform which we are using to visualize, which you are already familiar, like Prometheus, Loki, Datadog, Grafana Cloud, etc. So here is the fundamental design of OpenTelemetry collector. So it has 3 modules, as I mentioned: receiver, processor, exporter. As from the name, you can see that the receiver, the task would be to receive the data. It supports multiple ways to receive the data from the existing things. Like, if your application is already emitting Prometheus metrics, you can basically plug it, and it will receive the Prometheus metrics. In case you want to see like in case of Postgres, we have the logs. So we can basically use something called as file log receiver to basically tail and get the data in our OpenTelemetry collector. Then we have something called as OTLP, that is the OpenTelemetry protocol. When we use the SDK in our microservice or any application, it basically emits the data in OTLP form, which is very efficient and can be plugged again and again. And for example, like, there is this receiver, processor, and exporter. it receives the OTLP data, and it can also export the OTLP data. So you can make this very, like it's like a Lego. You can connect one OpenTelemetry to other OpenTelemetry to, achieve scaling as you want. So the second module is the processor. Like there are many kind of processors inside the OpenTelemetry collector, or you can write your own processor also. It's highly extensible. For example, I'm focusing on very important processors like filter. You don't want all the metrics data to come to your platform. You want to filter some of the redundant metrics which are not important to you. So to save on the data cost, because it can generate petabytes of data if your system is very complex and very big. So then we have something called as attributes. Attributes are like labels in normal language, where we can add labels or replace the labels. For example, I have a metrics coming from service 1 and logs coming from service 1 and service 2. They are correlated. So I can make a label that this are related to app 1. So for that, again, we have the simple batch processing to achieve network efficiency here. Like we can batch all the metrics and this data, telemetry data here. And then finally, once we process all the data, it's very fast, and then we can export this data. By exporting the data, I mean we can connect it to any kind of observability backends like Prometheus, Loki, or you can write your own backend which will be able to understand OTLP format. So this is the format which we use. Next is like we want to connect all the dots now. Like we have the Postgres, we have the OpenTelemetry. Postgres, we can use SQL queries to generate the metrics, and we have the logs. Now we want to monitor our Postgres, which might be running in any kind of platforms. So for that, we have this. For example, here is our deployment platform. Like I'm deploying my Postgres in Kubernetes using cloud native PG operator. Then I can deploy this on bare metal. I will, in my demo, I will try to deploy it on my system locally. And then we can also monitor any kind of managed service providers where we have this things like AWS, RDS, Aurora, or like Big Animal and this thing. And then we basically will use OpenTelemetry to collect all the metrics data to a single place using the receiver here from different platforms. And then for the metrics, because we can also write our own UI, custom UI, and custom things to visualize better. But we have this open source tools like Prometheus, which can basically visualize this data for the metrics. And for the logs, we have this Loki. So we can use that Loki to basically, these are the observability backends, which will basically collect the data and store it. For Prometheus, we have PromQLs, etc., to query the data. For Loki, we have LogQL, etc. But at the end, we want to make sense of that data. So we'll use Grafana to achieve a unified view so that we can correlate the metrics and the logs altogether. So here it is. Like this is what we are going to achieve, and how. That is the important question. Do you guys know about Cloud Native PG, or shall I go in depth about that? Like, because I'm okay. So I'm just give a brief of Cloud Native PG, that it's a Postgres operator for Kubernetes, and it is a CNCF sandbox project, and which is open source, and it's 100% open source, and it is used by many companies in production, including ours. And it is cloud native by design. Like we have the custom CRDs named as clusters, which basically represents a Postgres cluster where we have one primary. We can have multiple standbys if we want to achieve high availability. And it is full declarative. Like for the Kubernetes people, they know why we need this thing. And the lifecycle management is like it supports scaling, failover, minor and major upgrades as well, and it uses this streaming replication to achieve the high availability thing, and it does not rely on the stateful sets. It's stateless, like it uses PVCs for storing the PG data. PVCs are persistent volume claims. So this is the basic about the cloud native PG here. And it basically, Cloud Native PG, when we are running that in Kubernetes, it basically exports the data in Prometheus format by default. There are such, you can deploy the Prometheus stack, which we are going to use in the demo. And then we have this logging thing, where we can output the logs in the JSON like we do in case of microservice when we deploy in Kubernetes, that it's logs in JSON format. So it supports that. Now, going back to the OpenTelemetry here. Here is a very simple pipeline of OpenTelemetry. So by pipeline, I mean to say the configuration, which I'm going to show in the demo. If you want to understand what we can use for Postgres, is this one. Like the host metrics receiver can be used to monitor the system level metrics like CPU, memory, disk IOPS. Then we have something called as PostgreSQL receiver or the SQL query receiver, which basically you can write your own custom SQL to collect the Postgres metrics based on your application if you want, or based on your extensions if you're using that. And you can use the standard Prometheus one also to collect the Prometheus metrics as a receiver. And then you can use file log receiver to basically read the tailed version of your file log so that you can stream your file logs to OpenTelemetry collector. And then we have this processor. As I mentioned earlier, like the attributes are basically used to add, update, and delete the custom labels. We have filter to keep the relevant metrics. It basically used to save the storage cost if you don't want to get the relevant metrics, irrelevant metrics, sorry. And then we have this batch thing, where we basically want to batch to achieve the network efficiency for performance. And finally, we can use the exporter. For the demo, I'm using, because I'm not sending it to my custom dashboards, I'm using Prometheus to basically send the data to the Prometheus remote write server. It can be anywhere. And I'm using Loki here in case of Prometheus to stream the logs to Grafana Loki. Next, we have this is OTLP. We are using OTLP here to connect different platforms, one OpenTelemetry collector to other OpenTelemetry collector. The config file looks something like this, where basically for the service thing, like if you see there are pipelines. There are 3 different pipelines we can have, one for metrics, one for logs, or one for traces. Here I'm focusing on metrics and logs. Again, going back to the metrics, we have the receiver, Postgres receiver, host metrics receiver, Prometheus, whatever. Like we can have multiple receivers in the same OpenTelemetry collector. And then we can process it whatever like we want. And then we can export it to multiple backends, not a single backend. So that's make it very relevant to unify the things. Similarly, for logs, we have file log receivers. I want to filter out some irrelevant logs, like I don't want to see the info logs in case, because that's are not relevant for me to debug here in some cases. And for example, I can export it to Loki and OTLP. So here is a very basic and fundamental pipeline for OpenTelemetry. This is what we are going to achieve in Grafana dashboard. Grafana has something called as Explorer tab, where we can split the screen based and chain it with the timeline. Here we can't use the correlation ID as far as I know. So we are going to use the same timeline, and on the same timeline, if there is a metrics spike, we can see the logs during that time to gain better information on what went wrong during that particular time. So we can correlate the metrics with the logs using this Grafana Explore feature here. Time for a quick demo here. This will be the demo setup. Here, if you see, let's focus on this part. I'm using Kubernetes because it's very easy to deploy these applications. So I'm deploying the Grafana Loki Prometheus here, and this thing inside the Kubernetes cluster. And I'm also running this Cloud Native PG on Kubernetes. And I'm also deploying this OpenTelemetry collector in Kubernetes cluster. And this will basically receive all the data and send it to Grafana. This is where we are going to have our unified observability thing. But as I mentioned, it can be running on the multiple platform. So if you see, like, we have some cloud service providers that I will not go in depth here. But if you see, like, some of the customers might be running the data in bare metal clusters. So what we can do is we can deploy a OpenTelemetry collector binary there, OTel binary there in the bare metal, and configure it in a way that it will send the data from this exporter to the other OpenTelemetry collector receiver. I hope like this is clear. I will go in depth in this again. But this is the basic setup. It's very simple, though there seems to be many components, but it's quite simple. So I'm using this tool called as K9s for my Kubernetes clusters to better visualize my cluster here. So if you see, I already deployed this thing. Like for the observability backend, I have deployed this Grafana. Then we have this Loki, and we have this Prometheus, which are running inside a container. Now, for the OpenTelemetry collector, you can see that I have deployed this OpenTelemetry collector in this namespace, where my collector is running. And for the Postgres on Kubernetes, I'm using this CNPG operator. So for that, this is the controller, and in my default namespace, I have deployed this cluster, where we have this pgconf EU. The name of my cluster is pgconf EU. And if you see, this thing, like the config of the OpenTelemetry, let me just zoom in. So as I mentioned, there is this pipeline thing. You have multiple pipelines also for the metrics by using this slash thing. And if you see, I am trying to receive the data from Prometheus endpoint here, which is running here. And then I am also writing my custom SQL receiver, where I'm using this connection thing. I'm using the read-only connection here, using this port. This is my user. This is the password. There are other ways to set the password in production. And I'm running a very simple query. Like, I'm running that select 111 as count, and it will basically generate the data here. And I'm naming that metrics as this thing, SQL query demo custom. And then I'm basically tailing this log, which is the Postgres log, which will be generated here. And I'm starting to get it from the beginning, all these logs. Once I have these logs, I'm going to use this batch processing thing, and I'm attaching a label so that I can identify that this particular resource is coming from CNPG. And also, in case like I'm connecting my bare metal thing, so I can say that the source are external. So I'm adding this new metrics here. And next, we have this filter. Like, I don't want this particular metrics, CNPG metrics exporter. This is not relevant to me, so I can filter out. Similarly, I can filter out my PG bench logs that I'm using just for benchmarking or testing my system performance here. So this is these are the processors. Now, going to the exporter part, which is important, I'm using this debug, which will basically show us what we are basically collecting for like dev purpose. And we are sending this to Prometheus backend. As you can see, this is my namespace and the pod. And I'm sending this data to Prometheus on the metrics one, and sending my logs to the Loki one. And this is how my pipelines look for the external one. And for the CNPG one, the pipeline looks something similar like this. Now for the logs, we have this. And for the CNPG, we have this. Now let's go for the live demo. Okay. So since my Grafana is already running, I can simply port forward my Grafana. So if I go to my Grafana dashboard, I can go to this drill down, first of all, to see what metrics we have. Like, these are the metrics which CNPG which is the Postgres running on Kubernetes, is emitting like, if I go for the very basic one, is the CNPG backends total. So how many connections, how many clients are connected to my Postgres cluster? So I can see that these are the metrics which are connected, and it is generating some labels to understand that which database is connected, which are the instance or the application name, stuff like that. Now, as we can see, these are like these are the lots of metrics like which are getting generated. Now, if I go to explore, I can select the source as Prometheus. Now I want to look for the backends total, just to see that it is there, like we can visualize it. I can filter based on label. We attached this label CNPG here to understand that these logs are coming from CNPG. I'll see the logs of this 5 minutes. As you can see that it is having, because it's a high availability cluster, so we have this 3 connections which we can see to the primary. One connection each for this one, and we can basically aggregate to see that these are the total connections which we have for this thing. Now there is this functionality called a split, where we can split this thing, and we can select any other source like Loki here, which is connected to our Grafana, and okay, these logs are missing. Okay, I think some logs are missing, so I will go for 24 hours. Let me restart my OpenTelemetry collector. Meanwhile, it's restarting. Meanwhile, what we can do is basically connect the Postgres which is running locally on my system. So for that, I'm going to open a port here, 4317, which is the default port for OpenTelemetry to receive the data. As I will go back to this to better understand, like I'm trying to, I have opened a port here so that I can receive something running on my bare metal. So I am running this Postgres cluster locally on my system, and I am using this basic config here, the bare metal hotel config, where I'm using my localhost port, my username, my password, and connecting to this database to grab some logs. I'm also using this host metrics to see some host logs in my bare metal cluster, and I'm basically trying to get this logs of my Postgres and send it to this 4317 port which I have opened. So I can simply run this binary. So this is the binary which is basically using this particular config file which I showed, and it is basically tailing, it has started watching this particular file. Now, if I go back and look for the label metrics which basically exist here. Again, I'm going for the very basic metrics, the Postgres backends. So if you can see, I have attached a label for to understand that this is coming from my local Mac. And if I see for last 5 minutes, you can see that by default it has 3 connections in my local system. And now if I split and try to get the logs here, if you can see, I can see some logs which are coming from my local system. Now what I'm going to do is basically use pgbench to mimic some extra connections so that we will see a spike on connections, and I will generate some error logs to get some data. So here we are. So I'm using the standard PSQL here. I'm using my localhost connection here to generate some data, some logs. So I'm generating a error log, let's call it, I'm generating a syntax log, syntax error basically. So let's call it pgconf eu, and the very simple syntax error is here. Now I can meanwhile run pgbench. I'm initiating some tables, then here I am mimicking 10 more connections to oops. Okay. So here I am initiating the pgbench tables, and here I am mimicking the 10 connections. So if you see that it has started and it will be running for 100 seconds. So for the 100 seconds, we should be ideally see that there are 10 more connections and 10 more spikes which are running. I'm going to refresh. Okay, so here it is. Earlier, if you can, I don't know if you can see the screen clearly. So if you can see that there were 3 connections. Then we connected using one more connection using PSQL. So there were 4. Okay, and after this 4 connections, like after we have this PSQL, we ran the pgbench, then which we, because the collection interval is 10 seconds, so you can see that data instantly, like there were more connections. So as you can see that there were 10 more connections, so the final value is 14, as you can see here. So for this period of time, there is this feature called as sync views. So based on this timeline, whatever timeline I'm using here, can be synced up with the Loki, so that I will see the metrics at that particular point of time and the logs at that particular point of time. And we can filter that particular error message also. Like we created an syntax error to generate an error log. So if I search for this, you can see that in my graph now, here I can see that this logs was coming from Postgres local file. The source was external, and it was my local Mac. It is coming from my local Mac. So for example, there is this high CPU usage or any kind of metrics which has surpassed your threshold. You can see the relevant logs of that. In case of your distributed systems, you can basically see the micro tracings as well, that what went wrong with the user request which flowed from one service to other service. So this is how you are achieving the unified observability. The next thing we have is, the next thing we want to see is that we have this. This is cool. This is fine. Now we want to also, like, because I have another cluster which is running on CNPG, which is running on Kubernetes using CNPG. So I also want to see my CNPG logs. So for example, here I have some old data, but yeah. If you see that we have for the CNPG, we have this particular spike, and I generated one error log here for the CNPG. If you see the resource ID is the CNPG, and the log file name was this one. So here we can, if I select for this particular interval here, we can see that during this spike, the metrics got automatically selected for that particular time because we have used this sync all features here. So this is how we can connect all the dots and achieve the unified observability using graph now. We can also write our own custom UI to better the user experience for the customers here. So this is all for the demo. Going further, like in today's world, like as you have seen that everything is moving towards the agents, AI thing. We want to have the natural conversation. We don't want to go in technical depth. So once we achieve this unified observability thing, we can use MCP protocols and agents and LLMs to query something in very natural language. Like I want to see that is my database higher than usual, so it will compare the historical data. The agent should ideally compare the historical data to understand the trend analysis that my metrics are going up or down. We have the CPU or the memory spike, which we can see that why it is going like that crazy. Then we have this, we can ask in natural language, like these are some of the examples which I generated thing. But this is the future of like observability, because we have the complex systems, and we don't want to get into very much depth also, like because we have very few time when there is an issue, we want to resolve it as soon as possible. And the good things with LLMs are that we can send lots of data for analyzing that. So but the LLMs wants the context, the relevant data only. So once we use the right kind of labels to categorize our data, we are able to retrieve it better. So yeah, this is like what we are going to achieve in very near future using unified observability. And here are some of the important resource links to if you want to better understand the OpenTelemetry thing. Here are some of the receivers which we have. There are some processors, there are some exporters, and then there are this Prometheus, Loki, and if you want to know more about the Cloud Native PG, we have the experts of Cloud Native PG in the EDB booth here, and some of them are sitting here. So you can connect with them, and I will be available at EDB booth in case you want to talk further. If you want to give some feedback, here is the QR code for that, for the same. And if you want to talk about anything about the observability, Postgres, Kubernetes, I'm also working on conversational AI out of curiosity, and this all things. I'm quite curious about the open source thing, so you can connect with me here, and here's the feedback link. So thank you, everyone.
Perfect. Are there any questions? But there are. Awesome.
Thank you for your talk. I would like to actually ask you, why did you decide to skip traces part of OpenTelemetry? In my experience, the visualizing slow query plan as trace with spans and color coding the spans with potential problems like too much I/O or too much blocks hits allows to push fixing the bad queries to developers as self-service.
Yeah. So actually, like at the moment, as per my experience, I've worked more on metrics and the logs part because that were most important at the start. Then we are working on the tracing part. So we can achieve that as well. Like as you mentioned with the slow queries, we can use some extensions to get that relevant query latency data, and then we can correlate that. So yes, that's in the pipeline. And that's totally feasible with this OpenTelemetry thing.
Awesome, thank you. Because I think that traces is the part of observability that was neglected in the past. We already have tooling for logs, for metrics, but traces is very new and awesome.
So that's the thing, like it's new, we are working on it. So once we have, I will, enhance it, yeah.
Any other questions?
Yes.
Perfect.
I have a question that is an extension of a previous question. So what kind of mechanism do you plan to use to inject trace context into the query? How do you plan to do that?
Honestly, like I'm not sure about that yet. Like it's still in the pipeline. We are focusing more on this metrics and logs for different platforms at the moment. We are trying to monitor different platforms and different cluster managers as well, like Petroni, EFM, Rep Manager, etc. So for the tracing part, I'm really not sure, but my colleagues can guide you better on this. So you can connect with us in the EDB booth, and we can chat about it. Yeah.
We have 5 more minutes. Any questions?
What kind of measures or metrics are coming out by default in relation with PG stat statements or PG weight sampling? that kind of stuff?
So, like, there are some default metrics which this particular receivers provide. Let me. So there are some default metrics which the receiver provides. The list is exhausting, but I can show you here. But we are not entirely dependent on this thing. Like we can write our own custom SQL to generate any kind of metrics. Like it depends on the extension you are using. Example, there are PG statements, there are EDB wait states, EDB statements as well. And so there are different kind of extensions, and everyone is like every extension has different SQL queries. So for that, like for example, if you use the SQL query receiver, so you can write your own query, and which will generate any kind of metrics for you to monitor. It depends on your use case, what you want to monitor. And this particular receiver helps with that. But with the PostgreSQL receiver, it basically have some standard metrics. So here you can't select any custom metrics or write custom SQLs. For that, we have the SQL query receivers. So it depends on your use case. You can use any kind of metrics here.
Okay, thank you.
Yep.
Any other questions before we run out of time? I saw the raised hand. Just want to give anyone else a chance. Otherwise, you get one more.
Apologies for stealing the mic again. I would like to answer to the person who asked how to tie the trace context and explain plan visualizing. The solution is to put the comment with trace ID and span ID into your query text. For example, in Vendor, in the beginning, one of the sponsors of this conference is created open source project to do just this. And they also donated it to OpenTelemetry Foundation. It's called the SQL Commenter. But unfortunately, OpenTelemetry Foundation said that they don't want to be bothered with that. And instead, it should be part of database communication protocol to pricing the trace context. And I believe it's an opportunity for us in here to start the conversation in the hacker launch or on mailing list of Postgres.
So yeah, traces will be the next big thing. Once we achieve that as well, it will be very easy to understand our Postgres system very well and to analyze the slow queries, query latencies. Yes, exactly. Yeah.
Yes. Or 1.5 more minutes.
Continuing that discussion, there's an extension called PG tracing on GitHub from Datadog guys, which does exactly what he was saying. So we should integrate that maybe.
Yeah, I will definitely we are working on this to include the traces soon.
That must be quick.
Just a comment, SQL commenter won't work for prepared statements. So this is a serious limitation. So this is why I agree it should be part of a database protocol and we should start the conversation about it.
Let's do it.
Checking. No further questions? Then thanks everyone and a warm applause.
Thank you.